Hi there, how's it going? Let's see, but we don't have the right. This is awesome. There we go. Okay. All right, so happy Tuesday. And I have on the agenda that we would look at Chapter 9 homework questions. I didn't know if you wanted additional practice problems from secant and cosecant type problems, or if the last set of homework questions on here is secant and cosecant, maybe we should work some of those. And then I wanted to give you an opportunity to talk about current events because there is a lot going on. So if you want to talk about how distance learning is going or what your concerns are for what the school year will look like in the fall, if you have questions or comments about the quarantine or the protests and such, whatever current event stuff you want to talk about. So we'll do that at the end. I'll turn off the recording before we do that. So it's just us talking and you don't have to be concerned about whether or not it's going to be posted to YouTube. And also we'll talk about, I'll give you a reminder about the norms when we have these types of conversations, that it needs to be, you need to speak with honesty and compassion from the truth of your heart so that we can share ideas freely and not be concerned about judgment or ridicule. Okay, so if you're good with that agenda, first thing I want to know is, do you have questions from the Chapter 9 homework? So you can chat them, you can turn on your mic and talk to me, whatever you want to do.
Yeah, could we maybe do like a variety of questions from like the homework, just like kind of like each, like from each section?
For
Right,
sure.
so we have like a fresher.
Did you have something in mind?
I was thinking maybe just like kind of like one from each, so like I guess like number 2 and then like number like 7, just like from like each like
Each
section.
column?
Yeah, each column.
Oh, sure.
Yeah.
Oh, no. Okay. All right, so number 2, this one says, given the right triangle that includes an acute angle theta with opposite side length 5 and hypotenuse 7, the directions were to draw the triangle and evaluate the 6 trig functions. So right triangle, so something like this and something like this, and then acute angle theta. I'm gonna put it over here. So here's my right angle, here's theta, and it says the opposite side length of 5 and the hypotenuse is 7. So there's my drawing. And then part B is we have to evaluate the 6 trig functions. So the sine is the opposite over the hypotenuse. Do you want me to show you these, or do you want me to talk you through my solutions?
I guess like talk through solutions, whatever would probably be like quicker, because I mean we get like the general idea of it, just like a refresher kind of.
Okay. So these are questions. All right, so number 2. So there's my drawing, which matches the drawing I just did. I need to find the length of this side, so I'm using the Pythagorean theorem for that. And I found that the length of this side is, the adjacent side is 2 square root 6. And then using the definitions of these 6 trig functions, so sine is the opposite over the hypotenuse, cosine is the adjacent over the hypotenuse, the tangent is the opposite over the adjacent, the cosecant is the reciprocal of the sine, the secant is the reciprocal of the cosine, and the cotangent is the reciprocal of the tangent. So is that?
Yeah, okay, so wait, first we find the adjacent, right? Is that what it asked you in the question? Okay.
Well, it's not asking for that, but in order to find the adjacent, like to find the cosine, you need to know the length of that side.
Okay.
So I'm just using the Pythagorean theorem here.
Okay.
To do that.
There are all the questions are gonna be right triangles, right? Or like most of them?
Yes. Yeah, that's geometry where you got not right triangles. In algebra 2, we got right triangles. Okay, so next up we asked, Jared asked for 7, but I've totally screwed this one up, and I just found that out during first period. So the directions is actually, this is 9. So I guess I'm switching that now. This is actually 9 in the instructions. And this, so therefore this is 9, yay pencil. And then we had to come up with the cosine of the 60-degree angle. So this is 9, which means this is 9, which means this is not 6, it is 9/2. So that's what's actually happening there. And that's, you can say that's fixed. Okay. So is that okay?
Yeah. Wait, don't we have to? Oh no. Okay, never mind. That was just like the other side. We don't have to find like the sine and the cosine because it's not.
Nope, because it's only asking for, question 7 is only asking for the length of the adjacent side.
Oh, okay.
So that's why we've used the cosine,
Yeah.
because that's what we're looking for, is the length of the adjacent side. And we were given the hypotenuse. So maybe if we were asked to find the adjacent side and we were given the opposite side, in that case, we probably would use the tangent.
Tangent. Okay. It just depends on like what you're like
Exactly.
given.
Exactly. So you kind of have to know the definitions so that
Okay.
you can know which trig function to use.
Okay.
Tangent, cosine, sine, whatever. Let's see. So the next column of problems, the one at the top of the page is number 12. So here we are with number 12. So they gave us the triangle ABE. The right angle is E. We know that angle A is 43 and the length of side B is 31. So the instructions started off with draw the triangle. So I've got A, B, and E as the right angle. The side opposite of A is lowercase a. The side opposite of B is lowercase b, and lowercase e is the hypotenuse. And we're told that this side is 31 and angle A is 43 degrees, and we had to solve the triangle. So the first thing that we do is we just find out how much angle B is by recognizing it's a complementary angle. So 90 minus, so angle E, right, minus A has to be this angle. So 90 minus 43 gives us 47 degrees. And the tangent of angle A, so this would be the opposite over the adjacent, gives us the tangent of 43 degrees equals A over 31, because that adjacent side is 31. And then we multiply by 31. And remember, your calculator has to be in degrees for this to work. So you put the tangent of 43 degrees in, and you get the side length is about 28.9. So just round to the 10th place, because that's what we always do. Almost always do. The cosine of angle A is going to be the adjacent over the hypotenuse. So again, we're starting up here. So this would be the adjacent, which is what we're given. We don't really want to use the approximation as the side. We would much rather use the numbers that we are given. So the cosine of 43 degrees equals 31 over the hypotenuse. And we're able to figure out that the hypotenuse is about 42.4. Is that okay?
Yeah, that makes sense.
All right, great. That brings us to number 22 is not there. 22 is over here. Okay. So the directions for this problem are to, given the angle theta in standard position, inscribed in a unit circle, so we had to sketch it. And then we had to evaluate the 6 trig functions. So 2 pi over 3 is our angle. That happens to be right about here. So again, standard position means this is the initial side, and this is the terminal side. And also I can see that it's like pi over 3 would be the reference angle.
All right, so Miss News, so the reference angle is like, is it like whatever's like to the x-axis, like to the,
Yep.
and then do we find, what did I say? Do we always go counterclockwise, right? If it was like negative, then we go clockwise.
Well, so, okay, so this is why the drawing is so important. So if this is 2 pi over 3, then pi over 3 would be our reference angle.
Yeah.
If we had 4 pi over 3,
Mhm.
then we'd count this way, and this would pi over 3 would be the reference angle.
Oh, okay. So it's whatever that's like whatever is closest to the x-axis.
Yeah. So if it was like 11 pi over 6,
Right.
then
Yeah.
pi over 6 would be our reference angle.
Oh, okay. That makes sense.
So it's just to the nearest x-axis,
Okay.
and whichever direction you're counting, it doesn't matter. Because the purpose of that is to be able to swing it around to what you know about that angle in the first quadrant. So that essentially all you have to memorize is the first quadrant, and you know the rest of the circle.
Mm-hmm.
You know the x and y coordinates for the rest of the circle if you know everything in the first quadrant. Does that make sense?
Yeah.
Okay. So we've got our drawing of 2 pi over 3, and we know that the coordinates are going to be -1/2 here because this is the negative x-axis, and positive √3 over 2 because this is the positive y-axis. And so the sign of that will be 2 pi over 3 equals the square root of 3 over 2 divided by -1 over √2. Oh yeah, no, so the sign is just the y coordinate. I'm sorry, I was doing the tangent. So the sign is just square root 3 over 2 because that's the y coordinate. The cosine is the x coordinate. The tangent is the ratio of the two, which simplifies to -√3. The cosecant is the reciprocal of the sine, so it's 2 over √3. The secant is the reciprocal of the cosine, so -2. And the cotangent is the reciprocal of the tangent, so -1 over √3. Is that okay?
Yeah, that makes sense. So like the tangent is just opposite over, or it's kind of like opposite over adjacent, but how do you get like square root 3 over 2 over -1?
Okay, so when you say the tangent is the opposite over the adjacent, that's kind of the geometry portion of it, right? But we've also talked about the sine being the y coordinate, and the cosine being the x coordinate.
Yeah.
And so if you're talking about in unit circle terms, then the tangent is going to be the y coordinate over the x coordinate.
Oh, okay, that's right.
And the cotangent is the x over the y.
Mm-hmm. Okay.
Okay, all right, so turning the page. Then if we look at question 32, here we go, because that's the next thing. So 32 happens to be this function f of theta equals the sine of 2 theta minus pi over 3 plus 3. So whenever b isn't 1, we have to factor that out so we can see h without the influence of b on it. And so we know that b is 2. This is a horizontal shrink by 1/2. We know that h is positive pi over 6. So remember, the h's change sign and the b's are reciprocals. And then, so h equals pi over 6. That's a horizontal shift right, pi over 6. And then k we can see is 3, which is a vertical shift up. I feel like we're pretty confident with those transformations. And then the graphing. So this is where it gets really colorful. So we've got our 4 steps for graphing. The first thing, we set b theta minus h equal to 0. And that basically confirms the transformation that we described horizontally in part A. We plug in 0 for the argument of the trig function. So in this case, that's the sine. So the sine of 0 plus 3. Remember, where am I going? Here. So the sine is the y coordinate of the angle 0, so the positive x-axis. So that's why this is 0 plus 3. Now, if this was the cosine, it would be 1. So what trig function it is tells you which coordinate, either the x or the y, or some combination of them to use. So that's why this is 0. And that gets me just 3, right? So my 4 additional points, I'm using the usual theta, which are the quadrantal angles around the circle. So we've got 0, pi over 2, pi, 3 pi over 2, and 2 pi. So that's what we're using for sine and cosine, also secant and cosecant. And then I consider the b theta minus h that I had originally, and I set it equal to each of these angles, just the same way that we did in step 1, right? So I've got 2 theta minus pi over 3 equals pi over 2, because that's this pi over 2. And then I simplify that to get theta by itself. I set 2 theta minus pi over 3 equal to pi, because that's this angle here. And I do all of the arithmetic to get that horizontal transformation. I set 2 theta minus pi over 3 equals 3 pi over 2, and I simplify it to get the horizontal transformation there. And then I do the same thing with 2 pi. So I like to check and see that I have a pattern. When I have the denominators are all the same, then I can just look at the numerators to see that this is growing by 3 pi over 12 every time. And so that confirms that I haven't made a mistake. Like if this was positive and increasing, then this one was negative, I would know somewhere I had made an arithmetic mistake. I should go back and check my work. So the next step is we take out the b theta minus h, we take the trig function and any a if there is a vertical stretch or shrink or reflection, and whatever the k is. And then we just plug in our usual angles. And that gives us those y values here. Again, there should be some sort of pattern. So with the sine, it's like this. The cosine, it's different. The secant, the cos, right? So they all kind of have a little different pattern for the y coordinates. Then based on the horizontal transformations and the vertical transformations, I go ahead and I plot my points. So we've got what, 2 pi over 12, 5 pi over 12, 8 pi over 12, 11 pi over 12, and 14 pi over 12 that we listed in our table. And then we just kind of duplicate that going the other direction. So we want to fill up our whole graph from left to right with the repeating pattern, whether it's sine or tangent or whatever. Our domain goes from negative infinity to positive infinity because we have no asymptotes. And the range goes from 2 to 4, brackets on both sides of that one. I'm thinking. Oh, that's amazing. Yeah, I have to do this right now. Okay. All right, so we've got the domain and range. Does that make sense?
Yeah, so secant and cosecant are the only ones with like unions and like vertical asymptotes, right?
No tangent and also cotangent.
Oh, okay.
Okay. All right, so let's see. So that was 32, and that brings us to 41. Just around here somewhere. Okay, so 41. So 41 says f of theta equals a tangent of 5 theta minus pi, and then plus 1. Again, b is not 1, so I factor that out. Then my description, so b is 5. That gives us a horizontal shrink by 5. Oh, that's not right. That's 1/5. We also have that h equals pi over 5. That's a horizontal shift right pi over 5. And then k equals 1 is a vertical shift up 1. Okay, so 41 part B, we have to do the graph. So the first step is to set b theta minus h equal to 0. And this confirms the horizontal shift that we identified in our description. Then we'll evaluate the trig function when the argument of the function is 0. So the tangent of 0 is the sine of 0 over the cosine of 0, plus that vertical shift. So the sine of 0, remember, that is 0. The cosine of 0, that's 1, because that's the full extension of the positive x-axis. So 0 over 1 is 0, and that just leaves us with the vertical shift up. So making our table, we've got the 4 additional points. Now keep in mind, this is a tangent function, which means we're using these negative angles. So negative pi over 2, negative pi over 4, 0, pi over 4, and then pi over 2. Because these values over here will be repeats of these values. So we only do half of the circle, and it's the fourth quadrant and the first quadrant. Okay, so you can see here I've made all of the horizontal transformations using that same method that we used in the first step, right? We take the b theta minus h, we set it equal to our different angles. And this one, I think I did that one first, and then, yeah, that one last, because I forgot what I was doing. And then the tangent, so if there was an a here and there's a k, so we do the trig function, we multiply by a, we add k to get our y-axis points. Does that make sense?
Yeah.
Okay. And then here's our graph. So I think we had, what, 2 pi over 20, this vertical asymptote, and then 6 pi over 20, this vertical asymptote. So we have this curve, and then we just recognized the pattern and duplicated that along the whole horizontal axis. So that brings us to the domain. Oops, this should have a union here. So the union of negative 6 pi over 20 to negative 2 pi over 20, and negative 2 pi over 20 to positive 2 pi over 20, and 2 pi over 20 to positive 6 pi over 20 union, dot, dot, dot. Because we can go either way, the pattern will repeat infinitely. And then the range goes from negative infinity to positive infinity here. Questions about that one?
No, that makes sense.
Okay, great. Let's see, so that gets us to number 50 and 54. I can do those for you because I haven't done them yet. 50. Okay, so 50 says we've got f of theta equals 5 times the secant of negative 1/6 theta plus 1. So part A is the description. So I can see that A is 5. That's a vertical stretch by 5. I can see that B equals negative 1/6. So that's going to be a horizontal stretch by 6. Just kidding. And a reflection over x equals 0 because there's no h term. Also k equals 1, so that's a vertical shift up 1. So that's that part of the description. So part B, okay. So part B, the first thing that we do is we set b theta minus h equal to 0. So negative 1/6 theta equals 0, so theta equals 0. Second step, right, because we said there was no horizontal shift, so there isn't one. So when I plug that in, we'll have 5 times the secant of 0 plus 1. And remember, the secant is 1 over the cosine of 0. So the cosine of 0 is 1. This looks like it'll be 6. Does that make sense?
Yeah. 1 over the cosine.
Okay, so
Right,
our
cosine is cosine of 0 is just 1 because it's the x, right?
yeah. Yeah, so this is the angle 0 and the x-coordinate is 1, that's the cosine. Okay, so our 4 additional points, we'll have our usual theta. We'll have our thetas to graph. And then we'll have f of theta. So this will be 0, pi over 2, pi, 3 pi over 2, and 2 pi. Okay, so with our color coding, let's see, we have negative 1/6 theta equals, okay, we already found this to be 0 and this to be 6, equals pi over 2. which gets us, when I multiply that, negative theta equals negative 6 pi over 2 or negative 3 pi. Let's see which one we need. So we'll have negative 1/6 theta equals pi, and that gets us theta equals negative 6 pi. The next one, we've got negative 1/6 theta equals 3 pi over 2, which means theta equals negative 18 pi over 2, which is negative 9 pi. Our last one. That'll get us what? Theta equals negative 12 pi, which is consistent with the pattern. So this will be negative 3 pi, negative 6 pi, negative 9 pi, and negative 12 pi. And then the y coordinates. Let's see, so this is 5 times the secant of pi over 2 plus 1. So I feel like because it's 1 over the cosine of pi over 2, that we're going to have a vertical asymptote here. And here's why. So the cosine, so this is pi over 2 here, the cosine is 0. So 1 over 0, that'll be a vertical asymptote for sure. Does that make sense?
Yeah.
Okay. So 5 times the secant of pi plus 1. So, whoops, not plus times. 1 over the cosine of pi. But the cosine of pi is negative 1. So this will be negative 4. So just to refresh your memory, this is pi and the cosine here is negative 1 because that's the negative x-axis. And we have 5 times the secant of 3 pi over 2 plus 1, and this will be 5 times 1 over the cosine of 3 pi over 2. But that's going to be 0 again in the denominator because here is 3 pi over 2 and the cosine is the x-coordinate. So we have 5 times 1 over 0 plus 1, which is a vertical asymptote. Does that make sense, people? Are we good with that, Kings?
Yeah. Every other one will just be a vertical asymptote.
Yes, right. Okay, so our very last one, we've got 5 times the secant of 2 pi plus 1, and that seems to be 1 over the cosine of 2 pi. But we know that that's 1 over 1. So that'll be 6 again, which is good. Do you see what I'm saying? That there's a pattern here too? So I don't see any reason like one of these isn't, like this isn't negative 13. Like that would be like, oh, that's not right. Okay, so here's our graph. So what do we want to count by? 3, 6, 9, 12. So this will be 3 pi, 9 pi, negative 3 pi, negative 9 pi, and let's count by, I guess we'll count by 2s. Negative 4, negative 6, negative 8. Okay. All right, so here's what we've got. Vertical asymptotes. Negative 3 pi. So here's a vertical asymptote. Negative 9 pi, here's a vertical asymptote. Which means there should be one here. And also one here. Okay. All right, so 0 is at 6. Negative 6 pi is at negative 4. Negative 9 pi, so negative 12 pi is at positive 6. So looking at this pattern, I can see this will be here, and I can see this will be here. So I've got like half a branch here, and this, like this, and this, and this, and here. So this technically would go like this, and this would go like that. So there's my secant graph. Is that okay?
Yeah.
All right. So let's stick this down, and then here's our domain and range. So the domain so we've got negative 9 pi to negative 3 pi, union negative 3 pi to positive 3 pi. Whoops, union, not comma, union. And then 3 pi to 9 pi, union dot, dot, dot. And the range is a little bit more complicated here. So it looks like we have negative infinity to negative 4, and we have from positive 6 to positive infinity. Questions about that? That's all good? No problems?
Yeah, that's good.
Okay, so any other questions? Any other math questions?
I don't think so. I think it was a good review, just because I like there was so much information on this chapter that I feel like kind of.
Yeah, and we kind of took a pause for APs, and yeah. Yeah, I think that was a good idea. Okay, so are we ready to talk about current events?
Sure.
All right. So people can stay, people can go. And I mean, I'd love it if you stay. You can also turn off your microphones or chat ideas or whatever. I'm gonna pause the recording so it's just us. But remember that we are gonna be honest and caring with our comments and perspectives.